In a second.
In a second, okay. Okay, great.
Alles klar.
Sehr offiziell, yeah. Very official. Nice. Okay. Yeah, that's for the versions. Using different versions of the same libraries within a binary is not a problem. But if you are exposing data structures from these libraries in your interfaces, then the clients of these interfaces needs to use the same version of that library as well. And that's why it makes sense to synchronize, at least within the crates that under your control. It's good to synchronize or use the same version of a common library. And let's go on with nested crates. Why would you organize crates like that? Why wouldn't you just add more modules? Yeah, modules would be a different way to add more code under a crate. But of course, there are build performance issues which you get in Rust if you do that. If you create enormous large cargo projects. Large crates with more than, I would say more than 10 Rust files within a crate is also already should be considered a code smell, and would be a candidate to be split up, because that can really slow down the build. So that's the next one. Let's look at real examples. So we have on the one hand, we've got Open Ethereum 2.7, which is about 2 years old, and the newest would be Open Ethereum 3.1. And let's look at well, we could actually look at a couple of benchmarks, what effect it has when you make these mega crates. And you see here in 2.7, when there's one library which is especially large, it's got especially a lot of functionality, which is called ETHCore. And this in 2.7 on this machine, which is a MacBook Air, a quite new one, it takes 72 seconds to build it. And that's just a library. That's not the whole Open Ethereum client. That's just that library. And after the improvements to the structure of ETHCore and splitting it up, doing this, the crate shattering, that kind of stuff, it got down to 20 seconds. And that's that's 3.5 times faster than it was in 2.7. And of course, 3.1 even has got more features than 2.7. Now there's one project, for example, if you would develop consensus engines in 2.7, these consensus engines were actually a part of ETHCore. They were not split out yet in separate crates. So if you would change a single line of code in the Click consensus engine, it would still take 8.5 seconds to compile. And in 3.1, where it's a separate crate, it takes 4.5 seconds. So that's almost twice as fast as well. So it really makes a difference when you have the same code, but split out in crates that are easier to manage. It's development becomes a lot more comfortable. And if you
have a question about this timings. So this is building from scratch, right? So this first
no, that's not building from scratch.
Or this is incremental building, so changing something and then recompiling it.
In both cases, as in the ETHCore case, I used the lib.is of ETHCore and just added a empty line, saved it and compiled. That's just a single line change.
Okay, that makes more sense.
After a full initial build, make one change in ETHCore lib.is. And with Click was the same. It's a one line change in the lib.is of the Click consensus engine. So that's a realistic workflow. I mean, you would change code in wherever you work, if you work in Ethcore or in the consensus engine, and then compile to see the changes. That's something that you do like when you work on it like 40, 50 times a day or something. So that if that is slow, it really impairs your productivity. So that has to be fast. So let's look at this. Sorry. So where is it? So here we got Open Ethereum 2.7. And yeah, as you said, we look at one specific crate, and that's Ethcore. Let's see how that is structured. And we see the cargo.toml file. We see the source file. And benches is also a special file that I'm not sure if you mentioned so far, benchmarks. But that would be also a part of a normal structure of a crate. You can have an optional subfolder called benches and an optional subfolder for tests as well. And the source folder, would be the 3 standard folders that you could use in a crate. And we see a couple of other
question. But benchmarks are not stable yet, right?
I don't know.
To the best of my knowledge, it's part of Cargo and they integrated it, but they are not sure it will stay the same, the API. Therefore, it's not a stable feature yet.
Yeah. It's extremely useful still. So I mean,
of course,
benches. I mean, I've been using it a lot. I'm not sure if I switch to nightly or if I always use nightly in that case. Yeah, but benches are really nice thing. I mean, that should be stable. That should get into stable at some point. Hopefully, if it isn't already. But yeah, let's hope. And but you see that there are a lot of other folders as well, and these are actually child crates. So we already have a couple of child crates even in 2.7. But if we go into the source folder, we see that's a lot of stuff in it. Yeah, that's a lot of stuff. And if you then open each of the all these modules, yeah, I mean, that's a lot of files. I mean, it's huge, and that's why it takes a long time to make any changes in any of these projects, yeah, in these modules. So that's if you see a crate that has got so many modules, so many source files. I mean, if you would count them up, I think it's about 60 individual Rust files. That's not a good sign. That's really slows down build times and development.
Sorry, does anyone know Hoodie? Because he's asking to join, but if nobody knows him, I also don't know. So
yeah,
fair enough.
And it's already
Let's go on.
already pretty deep into the meetup as well. So
right. Okay. Please continue.
So what the Open Ethereum, or back then the Parity team did is they went into this source folder and looked at what they can extract into separate crates, into child crates, and that's what they did. So let's look how this same repository, it's the same crate looks like in 3.1 in the most current version. So here's Ethcore, and we see that there are a lot more folders now, a lot more child crates in that folder. When it doesn't even fit on one page. So pretty much everything that was possible, they put into a separate child crate. So see, all of them have got their own. Here they're all the individual engines. So there's another subfolder for the individual consensus engines, and they're all child crates. You see, each of them has got very few, hardly ever more than 10 Rust files in them. So I think that's sort of a rule of thumb. If there are more than 10, then you should probably split it up. Let's look at the actual source folder of the ethcore crate and see what's in there now. And you see in the old version, when you open the source folder, there were a ton of Rust files just in the base folder, and then it had a lot of them in module folders. And that's really cleaned up now. There are only 2 Rust files in the base folder, where one of them is libis, which imports all the crates and defines the modules. And then you see that there are really 3 of the subfolders are for tests, and there are only 2 modules which are now actually an actual part of the of ethcore proper, and that's the client and the miner. That's 2 of the main concepts in Open Ethereum, and each of those only has got a handful of files in them. And that developing with that is a lot more efficient, a lot faster. I mean, at least twice as fast, up to 4 times or 3.5 times faster than with the previous structure, even though it actually has more features. So it's a lot nicer than it was before. And yeah, that's a nice before after. That was a massive refactoring. Broke a lot of things for us, but I think it was worth it. Are there any questions about this before after case?
Yeah, so is this refactoring also helping with like readability of the code or finding your way around? Or is it more complicated because you have all these huge import files that are just shuffling around modules?
I think it actually increases readability because it's much more clear what each crate does. So the actual ethcore only deals with the 2 main objects which make up the client, yeah, what you need to set up a Ethereum client. And that's the client and the miner. And of course the actual consensus engines are also nicely organized now. I mean, I actually went so far in 2.7. I also had the HBBFT crate, which I created and extracted and added a plugin system so that I could use it and stuff like that. And that made not only development a lot faster, but it's also made a lot clearer because one crate has got one purpose. That's also a clearer structure. So you see the Ethereum virtual machine has got now its own crate, and it's much clearer what each of these crates does. It does each crate does one thing instead of having one crate which does everything.
Mm-hmm. Thank you.
Mm-hmm. Are there any more questions about that? Well, we could look at the Fluence engine as well, but I put it there because I hope that we have got a programmer there of the Fluence engine. But I mean, the last time I looked, it actually was very similar, organized very similar. Let's see, maybe we can open it. Let's see, and organize it and analyze it together. So it was in Rust FCE. Let's do this we know. So let's see how that looks. So, and that's a more classic workspace. You see that actually has got only a workspace in it. That's not like the hybrid that we've seen in the Open Ethereum project. And under it, yeah, you've got the child projects, which are part of it. It has got more source files in it, but still not excessive. And yeah, here that's also a pattern that we see in the Open Ethereum code base, that we've got a utils crate. See, So yeah, a lot of crates. Yeah, when you see it here as well, that you split up the your code into a lot of crates and in favor of a bigger, faster build times, and just as organizational matter as well.
I just recognized I lack Rust knowledge. We have main RS, we have libRS, and we have modRS. What's the difference between libRS and modRS?
Modules, I mean, there are two ways to define a module in Rust. One is you can actually just add another Rust file, and that's the module. I mean, let's go into libRS, and there would be errors, for example, this mod errors. Yeah,
right.
That's one way to do it. You just add a file that's named like that, and then you import it with, or then you define it with mod errors in your lib.is, and then it will be imported as a module. But the second way to do it is to have a this would be, for example, mod module. Let's take mod misc. And you see there's no Rust file for that. There's no misc.is file. But there is a misc folder. And by default, it will look for a mod.is file in that folder, and then that would also be a module. It's a different way to do it with the same effect. So you could have a misc.is in the base folder of the crate, or of the source folder, or you can create a folder of the same name and add a mod.is.
A misc with a libRS is some, and inside we declare mod misc. That would be different, right? Because it's nested even one level more.
Yeah, I mean, lib.is would be the standard file that Cargo would search for when you define a library type crate.
Right.
So you would expect it in the base folder, but not in the subfolder. You would expect it in the source folder, but not in the subfolder under the source folder.
Right. Okay, thanks.
Okay. I mean, they are using more than 10 Rust files in some of the projects, but they are also they're not, none of the crates that I've seen so far are huge. That's fine. So in general, it looks like a very nice, neatly organized code base as well. And in the workspace organization, it's even nicer. Yeah. So that's actually nicer. Okay. Has anybody got questions about, or would like to investigate something in that Fluence engine code?
Too little familiar with the domain.
Yeah, I mean, it would. I mean, I used it as an example because in the hope that one of the programmers would be.
I understand.
Which isn't the case. Okay. So these, the performance impact of this reorganization, we already talked about. Tips and tricks. I mean, one thing. I mean, if you go to a Rust conference and somebody asks you what you use as an editor, then you have to say Vim, yeah, because otherwise it makes you look bad if you use an IDE or something. Because it's a little bit. I mean, especially on this. This conference is a little bit of snobism about that. I mean, if you don't use Vim, then if you use an IDE, you're not a real programmer. But at home, I then use an IDE because
what
it's
about
much more
Emacs?
Emacs, I don't know. I mean, I never even touched that. No, I mean, I think I mentioned before that JetBrains CLion is my favorite because it just works. You set it up on any platform and it just works. I mean, before I tried the Visual Studio Code, and especially when you want to do debugging, when you want to set breakpoints and do real-time debugging, it required a different setup on each platform. And with CLion, it just you install it and you can start coding debugging, and that's well worth the $200 for me. But of course, you can also work with the Vim and grep. But I think if you want to do large scale refactoring, yeah, like reorganizing the vector structure of crates and child crates and move them around, stuff like that, a good IDE like CLion does a lot of work for you. It makes refactoring a lot easier, a lot less painful. So I think if you are maintaining a large scale Rust project, then something like CLion is really extremely helpful to make project-wide refactoring and stuff like that. Then what's really cool is cargo build set timings. Have you mentioned that before?
No.
That's
I didn't.
that's really cool. That's really cool. It's only available nightly, but in Rust it's no problem to just use a nightly feature because they're just installed side by side. And what that does, it compiles all the dependencies, so the whole project, and times each of the crates, each of the build times of the crates, and then displays it in a very nice way. I mean, that's really impressive what they did there. I will show quickly how it looks like. So I compiled the click. Let's see which project that was. Engines click, yeah, this one. Because it's a good example, it exists in 2.7 already, so it was good to compare. Well, others were either completely different or didn't exist at all. So this one was a good one to compare the build times. And what you get when you execute this line, cargo plus nightly build minus set timings, is an HTML file, which then looks like this. So you get some outlines about how many crates did it compile and how many CPUs it used for building and how long it took and stuff like that. But then it also graphically shows how these were built, and it shows which were built in parallel, when the build started and how long it took. You see, which ones might be a problem. And this is a 270 crates, so that would be hard to analyze without such a tool. And it's quite a long list, yeah? So it's just to see how it builds, which ones in parallel.
Do you know what's the difference between blue and purple?
I mean, it could be. I'm not sure. Maybe it's build times and link times. No, I'm not sure.
Right, that would make sense. Linking after building.
Let's see if it got a
legend somewhere.
Legend somewhere. No. I don't see a legend. No, I don't see one. But it's really cool. It shows you all the stuff. So S pairings is the one which takes 74 seconds to.
All right.
That's by far the one which takes the longest. You can go all the way until it's finished. Here, click, yeah, takes 3.4 to 44 seconds. So you can analyze which one is a problem, which one gets built in parallel, and maybe how you can restructure your project so that you can do more in parallel. Then this is also a very nice diagram which shows which crates still have to be compiled, which are waiting to start to compile, and which ones are currently compiling. This machine only has got 4 cores, so you've got only 4 of those. In the background, you see the CPU utilization, which you see is pretty good. So probably it's hard to make that go a lot faster. But if you had any problems like idle times or something that's a project that blocks a build for a long time, stuff like that, you could analyze it in this graph. And then it also, of course, shows everything in the table as well, where you can see, and that's pretty useful sometimes. And you see which one took the longest time to compile. And what's really important is you also see which features it has been compiled. And sometimes it's some features are really taking a lot longer to compile than, and you don't even need them, which means you can look at that list and go through the features and say, I can throw out this one, that one, and spare like 60 seconds of build time that way. So this tool is when from what I read from others online, they say that's the only thing you need really. I mean, that's with that you can analyze your build. There's another tool which is called Bloat, which is similar but goes for the size of the binary, so you can optimize for the binary size. But if you just want to go for build times, then this timings is awesome. It's the best one.
What I missed in that thing, or maybe it's included, but is there a dependency graph of your crates? I mean, the first graphic looked like a bit like it, but I'm not sure if I really could find or what these lines there mean. Are they really dependencies, or is this just the build order that the scheduler took more or less randomly?
It could be dependencies, yeah. It's a really a complex project, so you get a lot of lines. But what else would they mean? Yeah.
Okay. So if you hover over them, then it shows.
Yeah, the extra highlight, yeah.
Okay, then they probably are dependencies, yes. Because, right, what else should that be?
I would like to see one with more than one dependency. Because, yeah,
there
I
should
have
be
to look up if
something that is used by more than one grade.
I think in general you need different tools in order to print the entire dependency graph. There is no built-in for that, but I posted one in the chat, Cargo Guppy, which generates the dependency graph.
Oh, that's also will be very useful, of course. Yeah, but they are nice tools. I mean, and you know, something like this I would like to have for C++, for example. would be nice to have. So in the
I guess there are many things that would be nice to have in C++.
Yeah,
especially for build tools.
Yeah. Yeah, but there are a couple of these tools and more than at least here, of course. You can go pretty deep with Rust. Yeah. Any more questions about that? Okay, then just after the last slide. So guidelines would be avoid bloated crates. So if you've got more than 10, I mean, you've seen in Influence, they've got one which has got like 15 or something. That's probably still okay. But when it goes like 20, 30, 40, 50, then it's really time to split those up. And especially with Rust, the Rust compiler does a lot for you, and of course that also costs performance. So you have to keep an eye on build times. I mean, the parity developers, they didn't start out with these massive build times, but just incrementally grew and grew and grew until they had a big problem where nobody could develop properly anymore. So I think it's really important that you invest in that you in regular intervals look into the structure of your code and investing in crate structure refactoring, and of course review the structure on a regular basis. I think that's important for a Rust project that is growing and keeps growing and becomes really large. And of course, you should follow all the rest of the good practices. Continuous integrations, code reviews, that kind of stuff is also, of course, a part of development of large-scale code bases. Yeah, that's specific to Rust. Is the build times can be murderous if you're not careful. Okay, that's the last slide. Are there any more questions we would like to discuss? Hello?
I'm thinking.
So at the moment, I don't have any additional questions.
Can you show me the benchmarks, how you do them? Because essentially I looked up how does it work in Rust, and because it wasn't stable like 6 months ago, I didn't look into them back then. How do you benchmark?
I think benchmarking would be a good topic for another one, but let's see.
Okay.
I mean, do you know lead code? It's yeah, I mean, I implemented a couple of things and implemented in parallel in C++ and in Rust, and there I used the benchmark a lot. Not sure if I got it on this machine, but let's see. Maybe you can benches. Maybe you can look into this one because it's really simple. It's like with a regular test, but you just you decorate your function. Oh yeah, I mean, if you are in because it's the same like with tests, you can of course tag it on to the bottom of your source file and just define it as a bench instead of a test, and then it will be run when you run bench. Yeah. These ones, let me see. If we go into that's the open here. Launches, the open Ethereum. That's in Core benches. So, yeah, I mean, it looks like it's stable because I think I've got the stable version of Rust by default.
Okay.
So you just have to type cargo bench. It worked. 552 crates it has to build. Yeah, but I mean it's really simple.
This bench call takes an arbitrary number of
bench is a function which is defined in that module, that bench module. Bench function.
And it's only run once, or how does it test?
I think, I mean, when I was working with this lead code stuff, that was really fine-grained algorithms. So it had to run each thousands of times to get into a confidence interval. So yeah, I mean, it's the benchmarking facility of Rust does runs it multiple times to account for the fluctuations. But it's very simple to use. I think this one is a more complicated use. I think there's also a macro which which makes this simpler. But that would be a nice. Well, I mean, a nice meetup would be if we took a couple of the examples which are lead code, and then optimize it as far as possible, and then discuss what made a difference. That would be actually be a great meetup as well.
Yeah, maybe I will also cover benchmarking because I didn't talk about it yet. So
yeah, benchmarking is super easy. I mean, on C++, I used the benchmarking facility of Qt test, which is very similar. And you just have a macro which you cover your code with, and then it will run it as often as it needs to get into a certain confidence interval. And this one works very similar. So there's really no big setup necessary. And I think this one is where you use the benchmark API at a very low level, and it looks like that. So in principle, it will do that. What you see here, it will do, but I think there's a macro which makes it that simpler, so you don't have to deal with it yourself. Okay. Yeah, and one guideline is also use a fast computer when you're developing Rust. That's also a good thing.
Well, your computer survives streaming to the web and at the same time compiling it.
Yeah.
But it's even compiling some primal sieve in there. Ketchup, okay. WebAssembly, okay. Details. Parking lot, interesting.
What crypto algorithm that could be?
I think parking lot is some sort of a memory management library. MIO is I think the old asynchronous programming library, the Metal.io. Clap is the command line argument interpreter.
Right, parsing, yeah, library. Parking lot is a library that provides implementations of mutex, RWLog, condition variables, and ones that are smaller, faster, and more flexible than those in the Rust standard library.
Oh, yeah, okay.
Also concurrency. So.
Interesting.
Yeah, I mean, in terms of optimization of compilation time, everything boils down to organize your crates. So in the best case, all the crates have a uniform size in that sense. All of them take the same amount of time to compile. And you can try enabling or disabling link time optimization and other stuff like that. Some other flags.
Yeah, I mean there are a lot of tips online as well. I mean some also recommend to use a different linker, to switch out the linker.
Okay.
But of course, Rust itself got.
Sorry.
And Rust itself also became a lot faster in the last 2 years. Okay.
Using a dedicated build server is also another idea in terms of continuous integration.
Yeah, but you don't usually rebuild from scratch. Yeah. So I mean, if you are working on a specific part of the code, then working on a fast machine and having a somewhat well organized code base usually makes you pretty efficient. Gives you nice turnaround times.
And do you use also this only type checking the code that you mentioned at the beginning? Is this still something that is useful, or do you always build to the binary or to the
Yeah, I mean, one thing you do, I mean, especially in large code bases like Open Ethereum, you practically always work with unit tests. Yeah, so you work in your own crate and you create unit tests and then you run the unit tests. And that's what I do all the time. Basically, I don't run any cargo check or anything like that. Just press F5 and then start the debugging session. Let's make a change, then start a debugging session, make a change. That's usually how I work.
Okay, yeah, and then the cargo check also doesn't help you if you need to run unit tests, because
no,
there's nothing to run that.
That's really only if you want to have if you want to build a lot faster than you would with a regular cargo build, then you can use cargo check. Cargo check. Because it does compile, but it doesn't create the build output.
Yeah, so it's probably just running the compiler front end without any of the optimizations.
Skipping code generation and linking, I think.
Yeah. So yeah, you probably will run the compiler front end and everything back end stuff.
Yeah, I think up to the mid-level intermediate, how is it called? MIR, mid-level intermediate representation. Yeah.
Okay, so you still run. Okay, you do the macro expansion probably.
Yeah, that's the first step, exactly.
Then the type checking, of course, because you want error messages from the type checker.
Exactly, and then borrow checking. And then you end up with the MIR, and that's where you stop, I guess.
Phase from the type checker.
Sorry?
Borrow checking is different from type checking in Rust.
I do think so. That's my understanding.
Okay.
It's a separate step as far as I know.
Okay. Makes some sense, yes. Or it's understandable. I just thought it's our type system.
Fair enough.
Yeah, expect it. After it compiles, it will run the benchmarks, which probably also will take a long time on my machine. But at least we could see that, how many times it runs or something like that. But as I said, I mean, I really enjoyed it. I mean, I did that like 3 months ago with the lead code stuff, and that was good fun. That was really good fun. Because on lead code itself, I mean, you see the contributions of the others, yeah. So you see, the versions they have, how much more performant they were, and you can try out a lot of different things, and you can try, of course, to be faster than fastest, yeah. And yeah, that's really, you learn a lot by comparing all these approaches and testing it out locally and see how it runs for you. Because of course, in these kinds of benchmarks, when you're running C++ and Rust, you may get very different results on your local machine than you see on these benchmarks on lead code itself. So you actually, I mean, you can't really trust. But if you see a code on lead code and it's the fastest, you can absolutely not assume that it's really the fastest on your machine.
Benedict, I looked it up what Steve Klabnik presented in July. And here he says the high-level intermediate representation expands the source code to simpler primitive statements. So type checking is done, and also the method lookup, which particular method is called in the type system, considering the trait system and generics.
Yeah.
And then in the MIR, in the mid-level or intermediate representation, this is all about the control flow, resolving the control flow. So I guess unrolling loops and stuff like that is done there. And here we also have the borrow checking. So actually they are even done in different steps. So in the HIR, we have finished the type checking, and in the MIR, we do the borrow checking.
Okay, that's interesting. Could you send me a link to that? Or
yes.
So this was a presentation or an article?
Yes, I presented that in August, on the 4th of August. In the slides, we can there I cited what Steve Klabnik presented, and I will post the link once I have found it. That was right after the webference. So sorry, first you get the link to the LaTeX source code, because there it's easy to point to the particular line.
Okay, yeah.
And then if you look it up in the corresponding PDF, pretty much at the beginning. Yeah, HIR, expand the source code to simpler primitive statements.
Okay, cargo check omits the generations. But I was just thinking it doesn't really make sense if cargo check would run control flow optimizations, right? So it's probably not doing that. So it's doing the borrow checking on the mid-level thing, but nothing to generate the LLVM code.
Yeah, that's a different step. So after the
Yes.
MIR, we have the code generation, exactly.
Yeah, but there are probably MIR to MIR optimization steps.
Okay, that's possible, yeah.
At least that's how a compiler normally works. That you have optimization steps that take one intermediate language, optimize it, and out the same intermediate language. Like this loop unrolling. You wouldn't do that in a translation step, but in an optimization step. Or inlining, constant folding, all these things. Yeah, look into that a bit more. Seems to be very interesting.
I have to leave it 9. Das, my wife and, also die Edith und ich, wir schauen uns gerade den Mandalorian an, was schon da ist. Sie mag den Baby Yoda so gern.
So this will be a race. 485, 486.
Ja, am besten ist, wenn man es einfach selbst ausprobiert mit einem kleinen Programm. Weil es ist wirklich einfach. Es ist wirklich super einfach zu machen. Also da muss man gar nicht nachdenken drüber.
Which kind of tools do you use besides RustUp, Cargo, and RustC? Did you install any other tools?
Yeah, of course, I'm using CLion all the time. Yeah.
Okay, CLion.
And CLion offers so much that I mean, my workflow is you change code, set breakpoints, debug through it, and that I can all do it right within CLion.
Okay, so you don't use, for example, Clippy?
No, I don't use it. I mean, one of the problems in the OpenTheorem code base is that tools like these, or even Rust format, for example, is not really a thing there. I mean, they've got very idiosyncratic style. So I mean, in my code, I mean, when I've worked with the guys from Poor Network, yeah, there were a couple of them that were really fussy about things like these. I mean, I learned a lot from them there, yeah? And there we always used, at least try to use Clippy as well. But I mean, of course, I use Rust format. Rust format I integrated in. I just put a shortcut on a shortcut key in CLion, and I use that after every edit, basically. But Clippy not in a while.
All right.
Yeah, and the OpenEthereum guys recently switched back to version 2.7 actually. So we are back in the mess we were 2 years ago. Because I mean,
what's the rationale? Why?
Because the old team, the team, the parity technology, they developed their own, in principle, a competition to Ethereum. So they were not really inclined to further invest, 10 developers into an Ethereum client, and that's where Thomas and me went to Berlin, and there we discussed how it would be taken over by the community, basically.
Okay.
So it has been taken over by the community, but with less resources. And the 3.1 version was just so bloated and had so many features in it. And there were a couple of bugs which nobody seemed to be able to fix. And they wanted to get back to a simpler times. And that's why they decided to go to 2.7, where there were a lot less features. And I think they're starting now to refactor it back into shape. But they deleted a lot of code. They deleted tens of thousands of lines of code, which didn't make sense for the mainnet, for the Ethereum mainnet. Yeah. I probably will wait a couple of months until I go there again. Currently, I'm working on the 3.1 branch still.
Okay.
But they did the reformatting actually. So previously the OpenTheorem code base was completely non-standard. It uses like tabs and very very different from what you normally would use with Rust format out of the box.
Right.
And the argument not to change it was that it destroys the Git history. But apparently there are tools for that. I haven't looked it up, but I brought it up in the chat there, and they said, "Oh no, there's a tool which helps there." So apparently there's a tool. If you make a refactoring like that touches practically every line of code, there seems to be a way to avoid that it messes with your history, or that just can still say, this line was added in that and that revision, and not everything stops at that one refactoring.
Okay, interesting.
Have you used one of these competitive coding websites so far?
Not yet.
Not yet.
Sorry, no.
It was funny. I mean, there are a couple of those. I mean, LeetCode is just one.
Right.
But LeetCode, I mean, because they publish all the attempts of others, it's very interesting. Not sure if the others are similar. I haven't tried them out.
I tried some of these Project Euler examples a long time ago, but that's not as fancy as the new sites where you have. So it's just a problem set without any rankings or server where you can run your code. So you have to check that yourself.
Well, they are inclined in terms of mathematics, right?
Project Euler. They are more mathematical than than other stuff.
Interesting.
Yeah, LeetCode seems to be more generic, really like typical use cases in programming, small snippets.
And they have a lot of content, It's everyday new ones, and they're pretty interesting, most of them as well.
Okay, it seems you can upload solutions there as well. At least there is now a solved by column. I don't remember that.
Oh, I remember. So I also did Project Euler when I was just finished my A levels back then in 2009 or 10. But I looked it up like 3 years ago, and I can ensure that 3 years ago there was already this feature where you can load up your own solution and discuss it with others.
Okay, then I just forgot about it.
Okay.
Or I never uploaded it and then forgot about it.
Yeah.
That there exists this feature.
So, how is your computer doing? Is it overheating yet?
Well, I mean, the fans are running, but it's okay.
Okay.
32 packages in 4 minutes. So.
Yeah. As I said before, Rust development I only do on my super fast desktop machine. I avoid. The laptops I only use for like emails and stuff like that. One of the problems is when I want to do the meetups on my main computer, is the format of the monitor is so unusual that I don't get. It's not good for sharing. It's not good for sharing. But for that, the MacBook Air is great.
What strange monitor configuration do you have to do? Just
Yeah, I mean, I've
work
got
for sharing.
the 21:9. You know, I've actually.
Okay, so you don't have multiple monitors, but you have one extra wide monitor.
I mean, I've got two. I mean, I've got one monitor and one 4K projector.
Cool.
On which I normally program on the 4K projector, because I mean then I've got a 3-meter screen and super easy to read and can work from the couch.
Okay, it's an interesting workflow.
Yeah, so awesome.
Working
I started with that like 5 years ago or something. First, I only bought it because I wanted to watch movies or play games or something like that.
I'm not really